Okay, awesome. Welcome to the seventh episode on machine learning for beginners. We have with us today Ajinkya Kolhe, and he's a data engineering and ML instructor working as a full time in Google. And The aim of this webinar series is to help newbies and beginners in the domain of machine learning get started and understand how the industry looks like and what are the key needs of being an ML expert. I'll just quickly introduce myself before we start off the interview. I'm Jay. I'm a research assistant at Arizona State University, pursuing my grad studies in computer science with a focus on artificial intelligence. Welcome Ajinkya to this webinar, and thanks for taking out the time on such an ungodly hour. So, thanks a lot for being with us today. Can you tell us something about your background and how did you get started off in the machine learning domain, and what is your take on that?
So like almost everyone in India, I'm an engineer, and majority of engineers, I'm from IT background, so my degree is in computer science. So I kind of started my journey into ML like most people do, is like out of fear of job safety of future. So with every job getting automated, so I thought let's learn this as well and see where I go. Uh, but I actually got interested in that, and I've been pursuing that with a lot of passion since I began in past 2.5 years. I think I began this journey in 2.5 years ago.
Wow, wow. Right, right. How would you describe your first kickstart into the whole ML domain? What was the first outburst for you, and how did machine learning look like when you started off your journey, and how actually it is as you see as of now?
Well, ML really has not changed at all. So I started learning that in 2050, and whether it is academia in India or academia anywhere else, we generally tend to focus more on the theoretical aspect of machine learning that has been constant since 1940s when it was invented.
Hmm.
Everyone knows, focus on maths, focus on statistics, focus on probability, linear algebra, everything. We go about deriving unnecessary things when the wheel has already been invented. No one really talks about building stuff. So everybody, it's like we all love Elon Musk, right? Elon Musk, actually, he was inspiration for Iron Man character Tony Stark.
Right.
So definition of engineer is someone who builds solutions. It's not someone who thinks about building solutions. It's like I think we in ML, whenever anyone start learning ML, it's all about just go into unending black hole of the maths part, theoretical derivation parts, but never actually going on to building stuff. That is what I observed while learning ML myself. First few months, first not just few months, 4 5 months, I was into unending loop of books of Peter Norvig and 2NG courses and all the recommended studies, all the recommended books, but where they are not really for someone who is looking to build solutions immediately.
Right.
And that was one spectrum, and the other spectrum was all the medium blogs which are available online, wherein they simply have copy paste code. You do something on Titanic, you do something iris data set, and never really understanding what you do. So
Right.
at one end you are understanding going into too much detail, at other end you are not going into detail at all. So that is how it still is. What has changed now is like the volume of information has increased, and that information is again adding to the confusion. So I
Right.
don't think things have changed at all. What is lacking is a middle way. So there are few courses which I like, is like fast.ai course is really good, and the approach which should be taken towards learning that is explained quite well in that course. So as long as we take the right path and we are focusing that we are engineers, where the actually building the product is important, as long as that goal is kept in mind, then you can shortlist, this thing is taking a lot of effort and we don't really need to do this now. I'm not saying we don't need to go into details
Right.
at all. I'm saying we need to do that after we are able to build the solution. So
Right.
that's my take on how should we learn ML.
Right. Like complementing something what you said is what I see as of now over here in academia. They mostly focus on benchmarking results and improving the state of art, and not a lot of focus is put on product development. And they mostly care about the benchmark results that the students try to prove, and if they are improving the state of art. So,
Right.
comparing these two things, is there these two domains, I would say, the academia and industry, is there a very big leap that students who would be bursting out after getting the degrees and into the industry domain, is there a big outburst that they have faced, or is it an easy bridge for them available over there, or is it something they have something very difficult to cope up with? What have you maybe experienced or saw as in general?
So I think academia builds unrealistic expectations about way the job is. A job. So everybody starts with a really idealistic way. It's like, I want to make a difference. I want to be passionate about my job. But whereas in reality, what happens is like, you might not be like everything the job has to offer, but you will also like something else you did not expect. So this is what
Right.
happens. I mean, I've gone through the same phase. My first job, I started with that mindset that I have to love the job, otherwise I'll find the job which I love. But it's like that. If you are not sticking through one thing, you will never stick through anything.
Right.
And that's what we have to keep in mind, even in a job like data science. It's like there are things which are interesting if you don't have a tunnel vision. It's like that's the thing. Data
Right.
scientists, we see projects like DeepMind, wherein a project which has crossed a benchmark of AI power. It achieved that benchmark 20 years earlier than it was possible.
Right.
So you can't really do that as your MS project or a BTech project. And
Right.
when you are kind of working on something and you think my data is only, let's say, a GB data and I'm doing only some classification, then that's the disappointment which comes with the job. It's the problem is really high expectations and the illusion in which how the job should be. The problem is with that. It's not really with the way work is present.
Right. Yeah. Yeah. I mean, thanks. Someone said it out loud. So, like, yeah, now I'm sure. Okay. That's the bubble bursted. So,
Yeah,
now,
bubble is always true everywhere. In India, it's like why everyone started doing engineering. It was because in the beginning there was a lot of jobs and lot of salary. Then there was next phase of MBA. Why? Because engineers became too much and there is lot of salary for MBAs. And now there is data scientist. Why? Because number of data scientists is less and salary of data science is high. That's the only reason. So it's all the buzzword without really understanding what are the skills to make a good data scientist. What are the
right.
skills to make a good MBA? What are the skills to make a good engineer? As long as we focus on skills, we like that job. And there are studies supporting that. Once you become good at something, you start liking it
Right.
because it becomes question of pride, whether it
Yes.
is gym or whether it is studies.
That's true. That's true. That's true. So, talking about, like, as you talked about DeepMind and data science, and you yourself being a machine learning expert as of now, so and working at Google, so and who is the best workspace to talk about all of these three domains? What would you define an ideal difference between the duties of what a machine learning engineer is supposed to do, or let's say a data science engineer is supposed to do, and say deep learning? Because we find a lot of fuzziness between these terms, and nobody knows what are the ideal expectations if I am applying for a data science engineer or a AI engineer or machine learning engineer. Everything seems to be overlapping on a lot of domains. So how does the workspace at least say Google differentiates between the duties of these three engineers, or and apart, and all of this combined with the exclusion of what a software development engineer does at Google?
Right. So it doesn't matter about the company. It's like distinction between ML and deep learning is constant. Whereas
Right.
AI, ML, deep learning, it all involves experimentation, wherein you have data, you have to find the best optimal solution and explain the results. So for that,
Right.
you are experimenting on the model. The model could be ML model or deep learning model. So, I mean, that is like if the data is kind of like videos, audios, text, where there are not really fixed patterns, the patterns which are codified kind of rules, then we use deep learning, otherwise use machine learning. If you're using machine learning, we kind of all experiment on features, we kind of have a lot of weightage on domain knowledge, extracting features, and then running the experiment on the predefined algorithms. Whereas in deep learning, it's more about the architecture. And yes, we have to understand the data, but the feature engineering has less weightage. So you are
Right.
only what changes is like how the modeling is actually run. And depending on how the data is, whether it is should be followed with ML or deep learning, only that thing changes. Otherwise, generally the approach is similar. It doesn't vary that much.
Right, right. So, like, also you talked about how the workspace looks totally different of what the ideal expectations is. So, how would you describe what are the ideal, like, if I were to, let's say, term the experience of a day in the life of a machine learning engineer at Google, how does a day look like? You yourself are an instructor, so like you might be knowing what are the projects maybe some of the ML experts work on. So how much focus is on, let's say, what how much expectation is out of an engineer to be on, let's say, scalability or research or reproducing those results. What are the expectations of an or normal ML engineer at let's say Google?
Uh, let's say this thing. Let's say you are doing a small project. Generally, a small project lasts like around 2 months.
Right.
And in that 2 months, it's all about the data validation, all the feature engineering, all experimentation, and finding out the best fit, explaining the results, putting it on, let's say, a kind of web app or Android app or something. All that information from all that experimentation will take around 2 months.
Right.
Actual product of using the same thing, same data set, everything, it will take 2 years. So imagine everything you did and imagine doing it for, let's say, in 2 months, you finish the entire project. In job, you're going to do, let's say, just 2 months, you might be focusing on the scalability part. For 2 months, you are focusing on the visualization part, the interpretation part. So every stage is very calculated, planned, and it takes a lot of time because you have to ensure the scale.
Right.
And that's what I think people find boring because you don't get it's like I'm done in 1 day or 2 days and I move on to next part. That's
Right.
the difference in day of actual job, wherein we have to ensure the performance and the scalability and the maintainability of the machine
Yes.
learning model is present. That's it.
Right. Right. So, yeah, because you are an ML instructor as of now, what would you suggest, like, to the at least say beginners in this domain? How can they get started with this whole domain? Because I myself found it very confusing how to get started. I mean, amazing. If I were to Google what machine learning is, I'm sure I could find some great, interesting, as you mentioned, Tony Stark applications, but much of them are still not a reality in this complete domain. But I still got interested on what are the applications of machine learning. But how would you suggest would could be an ideal pathway for getting started with the basics and then understanding what is the state of art and maybe ending up at working at some great space who employs machine learning domain? What are the best set of resources? At least I know it can be a personal bias as of now because you might have referred to something of your own interest. How did you get started and what could be the do's and don'ts of using resources online getting started with machine learning?
Uh, what happens is this in India, we want quick results and we don't really focus on understanding, and that's not only just for India. So even if you look at the total number of researchers and scientists in the world, generally all their mindset is common. There is one common theme across everyone, which is curiosity, asking questions and trying to understand how something works,
Right.
how nature works, or how some model works, or how something is working, data is fitting some pattern, anything. It's that curiosity, asking questions and trying to finding the answer. So it's not about what you learn. It doesn't matter if you're learning machine learning or assembly programming or compiler studies or algorithm. Doesn't matter. How you approach any learning, that is what is important. And what I've found out is if let's say you approach learning right, you are focusing on understanding and you want to actually understand. Now, even in what I'm saying can be misinterpreted. So when I say
Yes.
actually understand what you're doing, then you can again go into too much details understanding of one thing. You can take just one thing and you can go to level of quantum computing in any field. So it's like again you are doing the tunnel vision of any one thing. In generally, the way our mind works is like, yes, choose a domain, But as long as you have a broader understanding first, you shouldn't really go deeper.
Right.
So, and to be invested in doing something is like if you can actually build it. That's how we actually get interested in something. Not like our education system where you study for 18 to 20 years and after 20 years you have that degree and then you start doing job. No, what it's like, if you can build something immediately, then we can see the result, we can go back, we can feel proud about what we have done. And that is how exactly guitar or any music instrument works, right?
Yeah.
If someone was playing actual song after 10 years of learning, no one would play any instrument. We
Yeah.
start with happy birthday song. It's like we can play that in a month and we can show off and we can put photos on Facebook while playing the guitar. We can play that guitar on tracks, and then we can feel proud. Then we can find out next song and again more compliments, and with that interest, that's how we keep going. Same thing here. Study, understanding way, not going into unnecessary depth, but covering the entire required breadth first, building something on top of it, then going into big details, then again building something on that understanding, and again going into depth. I think that's a more sustainable way.
Right.
If someone is, let's say, very driven and they are really passionate about, let's say, maths of data science. I know few one of my friend who is very interested in maths part of this data science. He doesn't really need to build, because he's so driven and invested that he can just study maths of it for a few years, I think.
Yeah.
But if you're not that, and I think majority of us are not, so the approach is do the breadth first, build, then again next level of the breadth and build, and you keep doing that in an iterative manner, and that's when you reach a good enough stage of being dev- a hireable machine learning engineer sooner.
Right. Right. So I guess the focus should be more on learning cloud platforms and the platforms that use machine learning to leverage applications, rather than focusing on a complete set of details of how the exact working goes beyond the ML algorithms, because it might take a long time or maybe a lifetime to understand those things. And so like the focus should be more on the applications.
It
Right.
doesn't even have to be cloud. The focus has to
Yeah.
be on building something. We could use cloud or you could simply use scikit-learn. It doesn't matter. I could simply use Flask API. I could create a website, and on that website, on the background, you could have that ML thing which is running. Again, as long as we are understanding what we are doing and trying to come up with a unique way of looking at the problem. So, I mean, I see on LinkedIn, everybody is doing some open CV based face recognition or gesture recognition. Everyone.
Right.
That's just, again, no one is kind of doing some unique contribution. Let's say we do want to take that. In I took the Tony Stark example. So in that this thing that was a technology, I think Magic Leap or something. Some using fingers, you have some gestures which are detected, and it was used to control something. So when that Iron Man movie had came, that was really popular, but I didn't think it went anywhere in terms of technology.
Right.
But right now, with the way things have changed, recognizing gestures and controlling something on the top of gestures is easy. So, developing thinking about actually finding out places in the real world where we could build the solution. That thinking is also important. No
Right.
one thinks about even the problem. Everybody takes, I saw this video, it's ready-made code is available on GitHub. Let's just copy paste that, change it to something, and upload.
Yeah.
No one is thinking on what they are doing, and that's the problem in everything, right? AI can automate mindless stuff, and if you are doing AI mindlessly, then what's the point of doing AI when it was actually supposed to automate patterns, and we were actually supposed to think
Right.
on finding ways to solve problems, finding out problems, not even solving the problems, but finding out new problems. We don't do that.
Right. Yeah, that's a great insight. And yeah, that is not something that they never thought of in that way, but yeah, that's true. That's true. And so, like as you mentioned, like focus on the application first, and maybe required research is demanded. Then you maybe deep dive into research.
Correct.
What are some of the platforms you would say one of the applications that one of the platforms that come on top of my mind is Kaggle, but Kaggle is maybe somewhat limited into learning those stuff. So
Correct.
what are some of the platforms that you would suggest, like maybe focuses on helping people to build applications or understand how the ML platform works? Maybe somewhat brief introduction to what the ML algorithm does is, but focusing on building applications. What are the platforms one could get started with?
Hmm. I think Kaggle itself is a good place, but if you just check at any competition, again, you start with a, let's imagine how an athlete trains. Let's say athlete is aiming for a gold medal. You won't immediately start with that gold medal record in your mind while training for it. So that's what exactly happens. If you start with a very difficult competition, you won't go anywhere. If you start with the Titanic and Iris, again, you won't go anywhere because it is done and tried and tested by everybody.
Yeah.
So there are only two spectrums: people who start with the highest price competition, or people who are only Titanic and Iris and they don't go beyond that. It's
Right.
like, again, be realistic in what kind of competitions to attempt, find a data set which is interesting enough, and then you can work. I love finding out interesting stuff. So I love watching as physics related stuff. I love watching astronomy related stuff. I watch a lot of animes. I do a lot of these things. So for me, let's say I were to do anything like that, I would love a project which involves these. For
Mm.
example, I want to take astronomy. So entire data of NASA, recorded by Hubble telescope and many other telescopes, it's available freely.
Right.
Live data captured by Hubble telescope is available for free.
Wow.
On Kaggle, there is a competition wherein you can actually find out total number of galaxies. The images are available. Google has made a GitHub source available of finding a planet from such images, detecting the gravity anomalies and finding out planets, and you can find your own planet if it has not been invented yet. Galileo, Galileo who invented, I think, Jupiter,
Yeah.
what he did was, telescope was already invented. Telescope at that point was actually used to check opponent's military. Instead of looking at the ground, he just pointed it up. He just changed the problem statement. He tried to find out answer there, and he has gone into history as finding out planets, and is immortal in that way.
Wow.
So taking that example for astronomy, if let's say I'm interested in physics, the data of CERN Hadron Collider, wherein like experiment which actually find out God particle, Higgs boson, which actually prove that Big Bang happened, that data set is available. A petabyte worth of data is available publicly. Or there is a data set more than 200 GB of all the anime characters. So if let's say I love Naruto, and if let's say want to use generative networks and I want to create Naruto, and I want to combine pose detection, and I want to, let's say, make him dance, or I want different expressions, or I want to convert black and white Naruto to color, because I would love to read that. So there is a colorized thing, so I can download the black and white animes, I can scale it, I can convert it to color, I can see how good the rendering is, and maybe again put it back online so that people can see and read or maybe upvote. So
Right.
I mean, this is what I like to do. I mean, that's anyway my time pass, so I would make a project out of it. So that's how kind of you find out things to work on, not just the competition, but something like fun.
Yeah.
Batman, Iron Man, creating suits, some drone designs. There are so many things.
Right. Yeah, I mean, having the basic knowledge of ML and applying it to something that interests you would be the best way to get started, and learning it from the very hardcore manner, that because it would instill a great sense of, as you mentioned, it sense of pride goes over there and sense of passion goes over there with it.
Right.
So yeah, right. And so one of the other questions that I had, how much importance getting into the domain of machine learning and doing some tangible work, how much importance does higher education or any kind of research place? Is there a need, a dire need for that? Is there a moderate need? Is there a no need for doing masters? And how much importance does it goes into the aspect of, let's say, if I want to get hired by Google in terms of machine learning projects, how much importance does having research or a higher degree, let's say PhD, masters, holds a value, and how much significance does it reflect on your profile?
Let me ask the same question to you. Let's say you are a co-founder of an AI company and you are looking to hire 100 people. What do you think would be the most important factor to for you to understand which candidate actually has knowledge or not?
Mm,
What is
may- Mostly maybe he has some projects on his profile and how he worked on that, in what timeline he worked on that, or
it? Right?
And maybe in few of the candidates I would look for experience, because having workspace experience is equally important, and academic doesn't teach you always all the things. And yeah, having at least one mentor with a PhD who knows in depth of how the industry looks like, because he knows the state of art of what the technology looks like. Most of the people just work on the implementation level. So maybe that's just my understanding, I might be wrong.
Again, these are different ways to check. There is no one way, right? Let's say someone has done a PhD and he has gone into details of actually doing ML. So he's a great candidate. Someone who has done PhD and who has just, let's say, copy pasted projects, just published some not really significant papers, again, he's not a good candidate at all. Someone who has not done any education, he might even be, let's say, he might not even studied beyond 10th standard or maybe. But if he has really interested in, he has invested himself, he has done a lot of project which actually involve significant work, and he has taken them forward, then again, that alone by itself is enough for us to understand that he has taken efforts and he has knowledge.
Right.
So degree has got nothing to do with it. It's like these are the different ways you can detect knowledge. Many people with degree, it's like one of the easier ways wherein knowledge could have been learned.
Right.
So if you have a 2 year degree, that's a more conducive environment to learn that knowledge, but doesn't necessarily mean that you will actually learn.
Right.
So it goes back to learning. It doesn't matter you're doing job, you're doing MS, you're doing PhD, it doesn't matter again. Thing which all we are aiming to do is like we are aiming to detect how good the knowledge of the guy is. Sometimes we detect correctly, sometimes we don't. So there is always that error.
Yeah. That's true, that's true.
So as long as you focus on knowledge, this rest doesn't matter.
Right. And also talking on the similar domains, at least what I interned back in Bangalore in HackerRank. One of the things that normally, because HackerRank is a recruiting firm, there were always some discussions going on, and they always talk about that most of the candidates do have the engineering capabilities, but they don't have the creativity or understanding of the application. How do I really apply this? Like you mentioned in the example of Galileo, that he knew the telescope existed, but he like the most of the creativity that goes to some significant discoveries, applying that discovery to something that's totally not thought of before. So how much do you think is that? Most of the people say engineering capabilities are maybe less than 50% important, but applying those things and working on projects, collaborating with team is much more important. What is your views on that, and maybe some external views, external insights on that? How actually is the problem with engineers getting, I would say,
Don't get me started
immersed?
on that.
Sorry.
Don't get me started on that thread.
Is it a real problem out there? I don't know.
So, see, I'm an engineer myself, and I've studied only those subjects which I like to study. So that's what alone makes me different. I did computer science because my parents told me to. I had no interest in computer science at all. I loved physics. So
Right.
while I was doing computer science, I was forced to do that. So I applied the same physics mindset. In physics, you understand the world. In computer science, I tried to understand the computer science, and I started having fun with it. Then AI/ML thing, I was afraid of my job safety. So I started learning that, and then I started having fun with it. So it's like that pursuit of knowledge, kind of like that Three Idiots movie, or even the way few of the scientists approach their studies. That's the kind of thing which is as the technical part. Then there is the non-technical part, which is the soft skills. In soft skills, everybody focuses on collaboration, teamwork,
Right.
and let's say conflict management. But what nobody focuses on, before we can actually collaborate, a team made up of two weak players will still be a weak team. So before we want to collaborate, we want to be the best person as we can. That's nobody focuses on. Two strong people should collaborate. So to be that strong, you have to, let's say, be driven, be right. So and the focus and dedication and the hard work. Like, I'm the last person who should be talking about this because I was neither focused nor dedicated nor driven. So it's these things, right? It's you learn that with time, and by the time you reach that stage where you realize the importance of these qualities, it's already too late.
Right.
So I think we just, again, the tunnel vision applies in everything, and we only learn qualities which we think are important and flashy. Everybody wants to become Steve Jobs or Jeff Bezos. Why? Because they are rich. And rest is
Yeah.
just, is like, style icon, and so many people, Mark Zuckerberg, blah blah blah. It's
Yeah.
like
Yeah.
they're just focusing on the wrong thing.
Yes. True. That's true. That's true. Yeah, that's really great. Right. And yeah, so I'll just like to conclude on this video, like by asking you this one last question. I normally, and it is one of my favorite questions I normally ask is, what do you think the ML trend, or in general computer science trend, looks like, and what is the new next big thing that you might have noticed along your experience journey, and what is the next big thing that looks like that is in the demand and a lot of people in the industry are focusing on, and how, and also one of the questions like how should one um, prepare themselves for getting into these jobs, because I know, like we mentioned in the last question, everybody has the technical knowledge, but it requires a great understanding of showcasing those talents and making it a right profile. So
Right.
what would you suggest? I mean, just blunt it out, like, don't do this, but do this, and definitely don't do that.
So in evolution, there is a concept called as mimicry. So what mimicry is this? Let's say there is a some poisonous butterflies. So what bird learns? That bird learns that these butterflies are poisonous, so don't eat them.
Right.
Okay. So let's say a butterfly learns that this is how a poisonous butterfly looks like. So a butterfly which is not poisonous, it learns to copy that visuals, so that it hopes that the other bird which is going to eat it, it will think that I am poisonous and it will not eat me. And the bird, he has to eat also. So he has to distinguish between which is the actual poisonous and which is the fake poisonous.
Right.
So there is a competition between them going on, since that's called as evolutionary arms race. So that arms race is like the faker learns to fake better, the detector learns to detect better, and that keeps on going. So someone finds a new way to fake, then over time that will work, and after some time, the guys who is catching that, he'll catch on. He'll learn that this guy is faking. So again, he'll start catching him. Again, faker will learn to fake something else. So this competition is kind of like many a times the reason such question is asked. So it's
Yeah.
like, how can I fake better so that I get hired? And once I get hired, I won't be fired soon enough, or I'll change my job before I get fired, so that I want to fake my entire life. I don't want to
Yeah.
study.
Yeah, that's true. That's true.
So that's generally the hidden meaning behind such questions, which I think it is. But as long as you focus on, I don't want to actually fake, I actually want to be the person,
Yeah.
then answer is clear. As long as you can build, because companies are no company is hiring data scientists to waste their money. Companies hiring data scientists to develop applications. If you can develop applications, you'll be hired. And
Yeah.
there is Kaggle, you can, there is hiring on Kaggle, or there is a website called as Academic Torrents. That's where there is a lot of large data sets available. If you want to work on large data sets, you can just take a swing on that. Or any kind of medical data, the astronomy data, physics data, chemistry data, genetic data, around genetic DNA, or there is, I think, some seed banks of the some extinguished species that is available. If you are interested in drugs, marijuana data set is available. There are, it's like endless things. You can take anyone, you can build a pipeline, you can, let's say, have some recommendations. And again, that tells you you can develop applications, you can put it on GitHub, you can blog about it, you can Reddit is a great place where actual knowledgeable people write. They can go through the project, they can give you insights, and 8 to 10 months is what it takes to actually build decent enough applications.
Right.
And
Yeah. 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 That's great. That's great. That's great. Yeah, I guess that's all from my side. Would you like to add any in general concluding tips from your side? Maybe just concluding something onto this webinar, lookouts, do's, don'ts again, in general, not related to machine learning or in just any software development domain, I would say. Any concluding remarks on that?
So, what's fun is actually like looking at history of something. For example, in deep learning, there is a library called as Keras. Keras library is actually part of TensorFlow now. But that
Right.
Keras library started as a project of full-time employee at Google. So Francis Cholet, I guess that's how his
Yes.
name is pronounced. He
Yes.
created that library. That library which was in the background was creating neural network and doing that gradient descent everything in background. And that became so popular that it exploded in popularity and actually became part of official TensorFlow. So
Right.
now go back to version number 0.001 of that Keras, maybe, and you see how he has written the code. You can actually see his thought process, how he builds, how he actually writes test cases, how the coding is actually done. Because anyone who writes code knows actual coding is easy, but making that code run, that takes months.
Yeah.
And initially, it's like even solving the problem, the debugging efforts which it takes. It takes around few months for you to get used to how to approach developing, and
Right.
you learn that after learning how not to develop. So that's kind of my way again tip from this in whether it is ML or deep learning. As long as you're actually building and you are asking questions, is this the best way? Maybe if I do something else, this might work. As long as you are thinking at every stage. So this thinking, have you seen Westworld?
Yeah. Yes.
With that Westworld, the Ford's dialogue when he's explaining that painting,
Yeah.
uh, that
Yes.
painting, that dialogue is really amazing. So, creation of Adam painting, painted in church, and really popular painting, Birth of Adam. So that talks about that if you look into symbolism of that painting, it is actually symbolism that a divine gift is our brain,
Yes.
divine gift is our thinking, human mind.
Yes.
And if we are not using human mind, we are as good as monkeys. So even while learning, we should be using our mind in actually learning. Is this the best book? Is this the best way? Is this the best approach? Should I be really using this? Should I be applying this way? As long as you do that, you learn and then you can proceed. That's how I approach.
Yes. Yes. That's great. I mean, yeah, yeah, like I'm personally myself a person who learns from a lot of examples, and yes, your insights learning from examples is really great because it makes the point really very clear, and it goes on to different, because most of the advices on how to get started on machine learning, I receive a lot of advices that are much more centric to person's perspective, but making it out in terms of examples is really effective way of communicating your thoughts. And I guess you being yourself a great orator makes it easy for our viewers to understand what actually the perspective looks like. So
Yeah,
yeah.
just take Westworld for example. I already mentioned Westworld. I just wanna add to that. So in Westworld, Teresa, I guess, romantic interest of the guy who is
Yes.
Bernard,
Yes.
right?
Yes.
So she's two ahead. Bernard, he is developer, and when they are trying to debug host, that process is actually debugging. They
Yes.
have regression testing. They have that everything. If you actually look at software development process and you watch season one of Westworld, you can actually find out a lot of processes.
The
How it's like the pipeline is
pipeline
maintained,
same is,
how they
yeah.
are testing the test, if they are rollbacking the model, how they are checking. You can see how much thought they have put in as a movie, as a TV show, to actually make it really realistic as a software development. If
Right.
you check at how the conversation AI is present in that Westworld, if you look at the tablet in which they code the
Yes.
host, you will see that actually has the decision tree of how a conversation goes. So, actual proper decision tree of how a conversation happens in chatbot, a realistic one. It also this is the path which could be taken, this is the probability of the path will go that way. That's how much care has been taken to make it that way in a TV show. which is pretending to do AI. And guys who are actually doing AI, they should obviously be doing that. So yeah, I think that's how you, if you think about it, that's how you have fun and you learn, right?
Yes.
I'm not about having doing work. I'm all about doing fun, having fun, and I have fun while applying it to these things.
Yes, yes, that's a major thing. Yes, yes, for sure. So yeah, once again, thanks a lot for joining on this call, and I really hope that this webinar is really helpful for new beginners to get started onto this and understand that okay, having fun is much more required than to learn, because that really instills a core understanding of what the domain looks like. So
So
yeah.
just one last point,
Yeah, sure,
one
please.
last point on that.
Sure.
So in many a times, what happens? Like let's say something worked for me, I'll say that's the only way to do that. So that's again a bias of the person is getting coming into that advice. So
Yes.
having fun, I used to think that was my bias, but it is actually supported by neuroplasticity. So
Yes.
neuroplasticity is the way rate at which your brain learns, and the rate is faster if you love what you're doing. The
Right.
rate is faster if you are driven to do that. The
Yes.
rate is faster if you are actually focused on doing that. So that's why it's like you learn 2 to 3 times faster when you're invested, when you're having fun, when you're enjoying that, when you're driven by yourself, and when you're getting the joy, when you're building these applications. So all these things is actually are proven as through neuroplasticity. So yes, having fun is a proven fact. It makes you learn faster, at least 2 to 3 times. And that's why many a times you might know people who work really hard but they don't have results to show for it, is because they are working hard when they don't want to. It's like they want to watch that cricket match, but they know they shouldn't. So they are just studying, but it's not really effective. Whereas
Yes.
someone who is doing time pass and watching the entire match and just studying for half an hour, in the end is more effective because he's focused in that half an hour, and for him it is like as effective as 2 hours. So
Right.
yes, having fun is important and proven by neuroplasticity. So that's my last thing.
Yeah. Yes. 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 Definitely. Definitely. Sure. And yeah. So thanks a lot for joining
Welcome.
and sharing your insights. Thanks a lot. Have a good day.
Welcome. Thank you. Bye.